Before I begin, it's been 2 full days of class, so thank you to everyone who's still here. Hello everyone, my name is Ananya, and I'm here to tell you today on how I plan on improving a process to restore one of our most important and fragile resources. My first dive was over 2 years ago. Clear blue water was a myth to me. Even though I lived in Singapore where water was a priority, all we had were dirty green reservoirs. I hadn't seen more than maybe 3 fish in the open sea until then. Shocking, right? I was so nervous and excited. As I backrolled in, I was suddenly overwhelmed by all the beauty and all the fish around me. I was so in awe with the way that everything was in sync. No matter how much they differed from each other, all the creatures and all the fishes looked like they belonged there. And that was what truly inspired me. Seeing different creatures connect and nurture each other like that. And I didn't forget that feeling. It made me want to do something. It made me want to help them and protect them. And it made me want to be a part of their beautiful, complex system. Since that day, I got my advanced and then later rescue diving certification. I took every opportunity I possibly could to be underwater and go diving. And that was my gateway to coral restoration. I was so happy I was finally getting that sense of being involved that I'd wanted. But something didn't quite feel right. Maybe it was the whole forcefully tying pieces of coral onto metal structures with plastic zip ties that wasn't sitting quite right with me. Sadly, that was the only form of restoration I had known. And even then, I knew I wanted to change it. So let's take a step back for a minute and understand, why are corals so important anyways? Over 2 million species of fish thrive on these keystone species. Our oceans would die if it weren't for these underwater rainforests to provide us with food, shelter, and protection from predators. Not only that, but corals break and absorb up to 97% of strong wave strength and supply over half of the world's oxygen. But since the 1950s, because of global warming, ocean acidification, overfishing, pollution, and so many other reasons, we've lost over 50% of our reefs, and it's on a downward trajectory. By the year 2050, we're estimated to lose over 90% of our reefs. That's a scary number. Because of this, restoration efforts are now more crucial than ever before. And as of 2024, there are reported to be hundreds of coral restoration projects worldwide. While this brings hope, it's only a start. Most organizations use a method called fragging, or fragmentation, which consists of breaking off small pieces of coral from existing reefs and tying them onto metal reef structures called reef stars with plastic zip ties. While it's great that we have these solutions, I really believe we need to evolve our method of transplantation. According to the US Geological Survey and Fish and Wildlife Research Institution, after 12 years of monitoring 75 transplanted colonies, only 9% of them were still alive. Another article done by the Tokyo University this year states that there are over 300,000 transplanted colonies in Japan. But most of them had a survival rate of only 20% after 4 years. I had set out with the intention of doing some light research on coral restoration, but I never meant to find such shocking news. After this, using zip ties just felt wrong. In a beautiful system where everything had a place, it was clear they just didn't belong there. It wasn't natural. It was like trying to force feed a child food rather than make the child something delicious that it would eat by itself. So I started looking at naturally healthy reefs, their shape, their surrounding rocks, and the substrate they grew on. And bam, there it was. The answer was staring at me right in the face. While it's impressive that we have these manufactured solutions, we need to improve our design so that they're more in sync with the environment, like when I first discovered the beauty of the underwater world. So I thought to myself, what if I could design a structure that didn't require corals to be forced on, but it was more of an invitation for the polyps to make themselves at home? This idea invigorated me to do more research, and by doing so, I found other applications of the Mars project. This particular Mars project was made by Reef Design Lab and stands for Modular Artificial Reef Structure. They 3D printed modular structures using biomimetics to replicate the shape of a natural reef to attract the coral polyps onto them. I was so excited to find an idea so similar to what I wanted to do. It gave me confidence to know that there were other organizations doing the same thing, and I knew I was taking a step in the right direction. But what was biomimicry anyways? It was a buzzword going around school, and it had resurfaced once more, and yet I only knew the bare surface of it. I found out that biomimicry is the practice of learning and mimicking from nature to solve human-made designs and problems. And it felt important to incorporate this into my project, as learning and mimicking from nature seemed like the perfect way to design these structures. My first idea was much like Reef Design Lab, to 3D print my structure. Except I wanted to make it with a material as close to calcium carbonate as possible, which is the material natural reefs are made out of. So I spoke to Finian, an expert in 3D modeling and someone who had been helping mentor me from the start. And he told me to sketch out my design and he could help me model it. This is what we came up with. Okay. I also managed to speak with an organization right here in Bali, North Bali Reef Conservation, up in Tianyar. I managed to get advice and help from one of the experts who worked there, but Kyle, and he guided me through the process of designing my structure. I learned from him the best dimensions to use for my structure and how I should make it bigger so that they don't get knocked over by waves or covered in sand. In doing so, I was disappointed to find that my structure was now too big to print with a normal printer and would require an industrial-sized one. Sadly, there were none available in Bali, but while there were some on neighboring islands, they never got back to me. So I went back to research, trying to find other options and other solutions. And someone gave me an idea to try out different materials as an experiment, such as acrylic or banana fiber. While doing this, I actually managed to get the opportunity to go down to North Bali and see some of their amazing structures underwater. They've made their structures out of cement, which has the same roughness and texture as natural reefs. So I was shocked to find so many amazing corals and species thriving around them. I also got the opportunity to speak to one of the biologists from the Biosphere Foundation, Ibu Gale. From both of these experiences, I learned how important it is to have good texture and a rough surface. So I went back and I decided I wanted to make more structures using these components in them. Through a few contacts, I met two local sculptors, Pawayan, who worked with limestone, and Bali Tantri Antiques, who worked with cement. It was amazing finding a sculptor who worked with limestone. I don't know why I didn't think of it before, as limestone is the same material as calcium carbonate, which is what reefs are made out of. So I started redesigning for more structures, but this time I wanted to incorporate everything I had learned. So that meant using the rough surface and the texture. I wanted to add more dents and holes for the water flow. But one more thing came to mind. This home isn't going to just be for the corals. It's going to be for the fishes who live there as well. This is what I came up with. As you can see, I went back to my original idea of making it modular, and I had connecting limestone pipes that could also act as tunnels for the fishes. I took my inspiration of honeycombs, as they're also hexagonal, and when you connected all 6 structures together, it would create a bigger hexagon. I gave my design to the sculptors, and when they told me it was possible to make, I went back to my acrylic and banana fiber one. First, the acrylic. I knew nothing about laser cutting, and this one required to be laser cut. So I took the help of Louis and the iHub team, who knew a lot about it, and together we managed to make a prototype. However, I was disappointed to find acrylic wasn't a good material for it, as it snapped easily and was very fragile. I decided to resin it anyway and deploy it just to see what happens. Next, the banana fiber. Once it was all woven, all I had to do was hang it in the shape I wanted it to look like once I applied the resin to it. However, due to certain complications, I wasn't able to finish them and deploy it, but I hope to do so in the upcoming week. Finally, my structures were ready. With the help of Matilda, Pakleon, and the Living Seas team, I was able to deploy my first one, the cement one, in Palangbai. And then finally, I was able to deploy the 6 limestone ones that I had been waiting for. I was so happy with how it turned out. Okay. I hope to be able to come back once a month to do maintenance and surveillance checks on both of my structures. And I want to add more structures so that when I come back in a year's time to see both of my locations thriving with marine life, coral, and polyps. I'd like to thank everyone who helped me make this possible. All the Quest teachers and mentors, Buck Ollie for helping me resin it, Buck Lowe and Finian for helping me mentor it, Louis and the iHub team, my friends, my parents for helping me and supporting me this whole time, Buck Leon, Matilda, and the Living Seas team, the North Bali Reef Conservation Team, and Puck Kyle and Puck Noah, and of course, Kimaya and Ninja for being my role models and supporting me. I'd like to end with a quote that I think resonates strongly with my quest. Corals are to reefs what trees are to forests. Thank you.